तो आज हम डिस्कस करने वाले हैं सॉल्यूशन ऑफ algebraic and transcendental equation in numerical method by Newton-Raphson method. So this is the most important topic get purpose. So आज हम डिस्कस करने वाले हैं न्यूटन रैप्सन मेथड. सो इस मेथड में हम क्या करेंगे, एक इक्वेशन दिया होगा f(x = 0). सो उसका जो अप्रोक्सीमेट रूट हम उसको निकालेंगे यूजिंग न्यूटन रैप्सन मेथड. सो लेट f(x) be the given equation, so let f(x) be the given equation and x0 be the initial approximation. So initial approximation to the root suppose xi. सो इस इक्वेशन का जो एक्चुअल रूट है वो है xi. सो उसके तरफ हम जाने के लिए हमारा जो इनिशियल अप्रोक्सीमेशन दिया होगा वो है x0. सो हम उसको यूज करेंगे टू कन्वर्ट टू द एक्चुअल रूट xi. सो ऑल्सो लेट f(x) is strictly decreasing function. So f(x) is strictly decreasing, that is f(x) is strictly less than 0. So and it is for all x. And also let f is convex curve. So that is f(x) is strictly greater than 0. So for all x, you can take an example of convex curve, that is y = x², is convex. Double derivative 2, that is strictly greater than 0. So this is an example of a convex curve. Now we draw the graph and this. So this is x-axis and this is y-axis. So we draw the function as a convex, so and monotonic decreasing. So we draw as this. So when it cut the x-axis at xi, so this is xi is the root of the equation f(x) = 0 and x0 be the initial approximation. So now this is our curve y = f(x). Now you draw a perpendicular from x0 to the curve. So this is the point. Now we draw a tangent line to the curve at that point. So this tangent line cut the x-axis at, so this is our tangent line. So this cut the x-axis at x1. Now we draw a perpendicular line on the curve. So this is our perpendicular line from x1 to the curve. So now we draw a tangent line at that point where the perpendicular line cut the curve. So this tangent line cut the x-axis at x2 point, and similarly we draw the perpendicular and then draw the tangent line and so on. So we converge to the root xi, पहले x0 फिर x1 and x2 and so on. इसे करके करके हम xi की तरफ बढ़ जाएंगे. सो x0 है, ये है हमारा इनिशियल अप्रोक्सीमेशन. So this is our initial approximation. Now we this is the graph. This is the graph of x, phi x. So this is our graph. Now we find the equation of the tangent line at the point x0 fx0, then the tangent, then the slope at x0, then the slope at x0 at the point, slope at the point x0. So this equals to is f dash x0, the slope, so derivative of the curve at the point x0. Now equation of the tangent line slope form, in slope form. So this is y minus k, y minus at that point, that is x0 fx0. So y minus y naught, that is fx0. So at that point we try to find the equation of the tangent line y minus fx0. So this is equals to slope at the point x0, that is f dash x0 into x minus x0. So the tangent line cut the x-axis at x1. So the tangent line cut the x-axis at x1, that is at the point x1 0. So at that point the value of the function is 0. So at x equals to x1, y equals to y, that is fx1 equals to 0, where y equals to fx1, fx, y equals to fx. This now from 1 we replace x equals to x1 and y equals to 0. So 0 minus k fx naught, this equals to f dash x naught times x, x1 minus k x naught. So x naught. So this imply minus f x naught upon f dash x naught. So f dash x naught, so this equals to x1 minus x naught. So this implies x1 equals to x naught minus fx naught upon f dash x naught. F dash x naught. So in general we write xk plus 1 xn plus 1, this equals to xn minus fxn divided upon f dash xn for n equals to 0, 1, 2 and so on. If we find the tangent line at the point x1 comma fx1 x1 fx1, so we find x2 equals to x1 minus k fx1 upon f dash x1 and so on. So in general we can find this formula, and this is the Newton-Raphson in our method. So we find for initial approximation x0 we can find x1, then x2 and so on, and so on. Okay.